Okay, so for this time, we're going to talk about composition of functions. We already applied the four fundamental operations of mathematics on functions, which are addition, subtraction, multiplication, and division. And for this time, we're going to learn the fifth operations on functions, which is called composition of functions. The notation for composition of function is, for example, we have here function f and g. That will be f composed with g of x or f circle g of x. And if we're going to rewrite that one, it will be f of g of x. Wherein we're going to substitute the value of the second function to the first function. Okay, let's have examples. So we have here two functions. The first is f of x equals x squared minus 6. And the second one is g of x equals 3x plus 2. So what is f circle g of x? We are going to write this as f of g of x. And then we're going to change the value of g of x here. And that will be f of 3x plus 2. And this means that we're going to substitute this one to every x of f. And that will be, we have here the value of f, which is x squared minus 6. And we're going to change every x with this one. And then we're going to have here 3x plus 2 squared minus 6. Okay, how are we going to simplify this one? If the exponent is 2, we can just have here. First, we're going to square this one, that is 3x squared or 3x times 3x, which is 9x squared, plus 2 times 3x is 6x, 6x times 2 is 12x. And then we're going to square the last term, that is 2 squared or 2 times 2 is positive 4 minus 6. And then we're going to combine similar terms. Then we're going to have here 9x squared plus 12x. 4 minus 6 is negative 2. And that will be our final answer. How about if we have here g circle f of x? And we are going to write this one, and that will be g of f of x. Then we're going to substitute what is f of x. And f of x here is, we have x squared minus 6. And that will be g of x squared minus 6. And then we're going to substitute this to every x of g. And that will be 3 times x squared minus 6 plus 2. Then we're going to simplify, distribute this one. And that will be 3 times x squared is 3x squared. 3 times negative 6 is minus 18 plus 2. And then simplify. And our final answer here will be 3x squared negative 18 plus 2 is negative 16. Okay, next, we have here g circle g of x, wherein we're going to substitute the function to itself. First, we're going to rewrite this one as g of x. And then change this with its value, that is g of x here is, we have 3x plus 2. And then we're going to change every x of g with this one, and that will be 3 times 3x plus 2 plus 2. And then simplify. 3 times 3x is 9x. Then 3 times 2 is 6 plus 2. And then simplify further. We're going to have here 9x plus 8. Okay, so that is how to do composition of functions. Okay, let's have another example. Okay, we have here three functions. The first one is f of x equals 12 plus 7x. And then g of x equals x plus 1. And the last one is x squared. And our task is to answer this one. And we can write this one as f of g of h of x. Okay, and then we're going to substitute. So first we're going to answer this one. So we're going to have here f of g. What is h? We have x squared So that will be g of x squared. And then we're going to substitute x squared to g. And that will be f of, what is g? We have here x plus 1. We're going to change this x with x squared. And that will be x squared plus 1. And then we're going to substitute this 1 to f. And that will be 12 plus 7 times x squared plus 1. Then we're going to simplify. So we're going to have here 12 plus 7 times x squared is 7x squared. 7 times 1 is 7. And then simplifying it further, we're going to have here 7x squared plus 12 plus 7 is 19. And our final answer is 7x squared plus 19. And this ends our discussion under composition of functions. Again, in composition of functions, we're going to substitute, for example, for this one, we're going to substitute h to g, and then we're going to substitute this one to f, and then simplify. Or if we have here only two functions like h composed with g of x, this means that we're going to substitute the second function to the first function. And that's all.